How are you? Hopefully your weekend was really great. Today we're gonna work with lesson 16.6, which is about scales. So remember, scales are very used in the context of architecture for sure, and drawing of all kinds. We actually need to understand what the word scale means, okay? Ratio. The scale is pretty much a ratio. Now remember, a ratio is a comparison between two numbers. And it's the ratio of a drawing or a model compared to its actual size or the actual measurements of whatever object we are actually working with, okay? Now, pretty much a scale rate, we call it a scale rate. It's what is the comparison we want to determine, right? We are usually comparing small units with bigger units, or a big unit to a very smaller unit. And so that is going to be the scale rate. Then we got to build a proportion to actually work the exercises out. So if we think about problem 2, for instance, problem 2 is about the dollhouse bed that we want to convert into the actual measurements, right? And so we have a scale rate. The scale rate is 1 inch to 1 foot. And they're telling us the measures of the bed are actually 3 inches times, or by, actually we say by, 5 halves of an inch. Okay? Well, actually, those 5 halves in the book are called 2.5 inches. Okay? I just converted into an improper fraction just because it's easier to work with them that way. So I have the scale rate. Remember, this is the scale rate. Oopsie. This is the scale rate. And now we're going to build the proportion to be able to find each one of them. Sure, I can call this one the length, and I can call this one the width. It's fine. And so we're going to begin with the length first. Okay? So the length is going to be 1.5 inch to 1 foot, right? It's equivalent to what? Well, we're going to work with the measurement we had, which is 3 inches, and we actually don't know what that measure is going to be. Of course, we got to do cross product, right? And I'm not going to work with the measures, the units of measurement yet, just because I don't want to get confused entirely. But let me show you how this is going to work. As you can tell, I want to find feet, right? So that's going to be the units I want to work with at the end as the result. So I'm going to have 1.5 s equal to 3, right? And then I got to use, of course, the reciprocal. Remember, I got to multiply times 2 on both sides, and this is going to cancel whatever is next to the x, and I'm going to have 6. Of course, again, I have 6 feet, okay? So the actual measures here, right now we're having 6 feet, okay? And then now we're going to find the width. So the width, again, is going to be, I'm going to use the same scale rate, which is 1/2 inch to 1 foot. It's equivalent to now 5 halves of an inch, and I need to find out what is the measurement there. This simple, we're going to have again 1/2 of x is equal to 5 halves, right? And I need to use the reciprocal, so I'm going to multiply times 2 here and times 2 here. That actually makes everything way too easy because I cancel these here and I'm getting x, and I can cancel this 2 here, so I know it's going to be 5. And I know that, of course, it's going to be feet. So I know I have 5 feet. Okay? So these two are the processes I should be working with. And of course, my answer is going to be this one over here. if you go to your textbook, and problem number 10 is actually using this diagram right here. And they're asking us what is actually the scale rate for these two drawings. And of course, we gotta compare the smaller triangle to the bigger triangle. Now, how does that work? Well, it's all in terms of measures. Think about this. I have 2 centimeters here and I have 6 centimeters here. And your textbook, it actually is just units, square units, right? So every time I have 1 centimeter here, I would have 3 centimeters here. And the other centimeter I have here, I'll have another 3 centimeters here. So my scale rate is actually 1, 2, 3. If I think about the other measurements, the same thing happens. I have 3 centimeters here, but I have 9 centimeters here. So the smaller triangle is compared to the larger triangle in our scale rate of 1, 2, 3. Okay, that's it. So this is pretty much the answer. All right, and then with that information, we just need to work on problem 12. I'm going to work with you guys for problem 12. Now, problem 12 tell us about length BC, which is 12 inches. So we know length BC is 12, inches, right? And that belongs to the small triangle. Okay? Now, please check on your book. Have your book with you at all times. Now, we need to actually have the measure of B prime, C prime, which is the length of the corresponding side on the larger triangle. Okay? And that, of course, makes us think about proportion using the scale rate. Now, remember, the scale rate is right here. So that's what we gotta use. So we have actually 1, 2, 3. It's the scale rate I'm gonna be using. That is equivalent to 12 to x, right? Because 1, it's the measures in the small triangle. And 3 are gonna be the measures, or how the measures compare to the bigger triangle. So if I have 12 in the small triangle, then I need to figure out what is gonna be the measure for the greater triangle. And again, I do cross product, so I know this is 1 times x, of course, is x. And 12 times 3, of course, is going to be 36. 36 inches is going to be our answer for number 12. Okay? Number 14 says the wingspan of an airplane measures 90 feet. A model of the airplane has a wingspan of 4.5 inches. What scale was used to build the model? So then, problem 14 is actually telling us about how a model plane is built based on the measurements of an actual plane. And they want us to actually find the scale rate. That means how is the scale for the building of the model, right? How do we get to do that? Well, it's pretty simple. We know there is 90 feet in the wingspan of the actual plane, and there is 4.5 inches in the wingspan of the model plane. So we are going to build a ratio here, which is 90 feet to, and instead of 4.5, I'm gonna say 9 halves, just easier that way, okay? I'm just doing the ratio. What I want to do is to actually simplify this ratio to the point I get a unit rate. If I get a unit rate, then I'm gonna be able to find the scale rate. And I'm gonna use inches as the quantity I want to get to 1. Now, as you can tell, I have a fraction here, and a lot of times it's not that easy. But how about I multiply, I'm gonna say times 2 down here and times 2 down here. Why do I do that? Well, if I multiply times 2 down here, I'm going to cancel the 2's and I'm gonna end up with 9 inches only, right? And then here I'm gonna have 180 feet. Then simplifying that is way, way too easy because I know it's actually 20, right? If I divide 180 into 9, it's actually 20. And I know I'm gonna have 20 feet for 1 inch. This is gonna be, yes, a unit rate right? But also at the same time, it is the scale rate for the model. All right? Okay. Now let's think about number 17. Anna and Ralph are making scale drawings. Anna uses a scale of 2 inches to 6 feet, and Ralph uses a scale of 3 inches to 6 feet. What is the ratio of the measures of Anna's drawings, to the corresponding measures of Ralph's? So this problem is actually pretty simple, guys. Like seriously, we just need to think about Anna's, right, which is 2 inches to 6 feet, right? And then we need to think about Ralph's, which is 3 inches to 6 feet, right? Am I right? Yeah. Now, if you think about it, they're both comparing to the same total. So it's actually pretty simple, because now I'm going to make a ratio between Anna's and Ralph's. So my ratio is going to be now this way. Anna's is 2 inches and Ralph's is 3 inches. So that actually means 2 to 3. That's it. So pretty simple, really. Alright then, well, hopefully this was useful for you guys to be able to finish the entire lesson. Don't forget we're going to be working on a model ourselves in class. See you later.